I'd now like to combine what we just learned in terms of analyzing the image with our eyes and introduce the second part of what we need in order to make a correction, and that is our video scopes, which allow us to actually measure the corrections that we execute. We're going to start right here with this image of Esther in her kitchen. So to get started, I'm going to display my video scopes. So I'll go to Window and then Lumetri Scopes. Now I want to display 3 different video scopes, and I'm going to come down here to my wrench, and I want to display Vectorscope YUV and Parade RGB and Waveform, and we're going to change the waveform type to Luma. All right, so the way this works is that you put the check marks next to the actual scopes that you want to display, and then down here, you choose the Parade type and the waveform type. So we want that to be RGB, we want this to be Luma. All right, so it should look something like this. Each of your scopes may be in a different physical spot within the Lumetri Scopes panel, but as long as you see these 3, that's what we want. And now let's learn a bit about what each of these is telling us. In the Luma waveform, I'm looking at the light and dark parts of my image, so no color information. Down here at 0 is video black, and up here at 100 is video white. The scope is read left to right, corresponding with the image. So overall, you can see that the image is not overly dark or overly light. Most of the values are hanging out here in the middle, between 15 and 75. That's something we already knew based on the analysis we did in the previous video, but when we did our analysis, we just said it was dim and muddy. This puts a value on that. As far as the lightest part of the image, it is her apron strap, which is about 1/4 of the way from the right part of the screen. So you can see that it's right here in the Luma waveform. So it's right below 80, measures around 78. So again, if video white is at 100, we're going to have to raise our highlights quite a bit. Now I want to try to identify where her flesh tones are, because we want these lighter flesh tones to register around 65 to 75. And sometimes you can just tell by looking, but one nice way to really make sure is to scrub through the image. Because people move and the background stays still, you can usually tell where the flesh tones are because those values are the ones moving in the video scope. So you can tell that the flesh tones are around 40 to 60, so we'll need to bring those up by about 15 to 20. Now, the darkest part of the wall back here measures around 15 or so we'll want to lower that down towards 0 if we want a true black. Now let's look at the RGB Parade. This scope measures our image across all 3 channels, red, green, and blue. Down here at 0 is video black, up here at 100 is video white. Again, we read the scopes left to right to correspond with the image. So we know that down here in the red, green, and blue channels, correspond with the darkest parts of the image here. And then here is the apron strap in the blue, green, and red channels. Also, as I scrub through it, you can see where her flesh tones are. Now, as we stated in our analysis, the image has too much of a cool color cast. You can see the blue channel measures above red and green. So in general, when color balancing an image, what you want to do is make sure that the image is balanced in the areas that are supposed to be color neutral, which are your blacks and your whites. So if you take a look at the apron strap, for instance, here, here, and here, it's much too high in the blues and the highlights, so we'll want to bring our blue highlights down, and we'll also want to bring our blue shadows down a bit too. Now let's look at the Vectorscope. This scope measures color values. It actually corresponds with the color wheel, and I'll select it so we can see it a little bit better and press tilde. You can see that we have red, magenta, blue, cyan, green, and yellow. In the Vectorscope, values near the middle of the scope measure very desaturated, and values near the outside of the scope measure very saturated. So here you can see we have very low levels of saturation across the board, hanging out mostly in the red, magenta, blue spectrum. When we correct the image, we'll want to bump up the saturation so we can return some vitality to the image overall. And then one more thing I want to mention is this line here, and it's called the flesh tone line. When you're correcting an image of a person, regardless of race, you want the flesh tones to reside along this line. So as we adjust our hue and saturation, we'll just make sure that we're keeping the flesh tones along this line. In addition, we want the flesh tone saturation to extend about 1/4 to 1/3 out from the center of the Vectorscope. Now, Esther has a paler complexion, so we'll probably be on the lower end of that range. So all of this said, I'd like to just describe the workflow that we're going to take every time we correct an image. First, we're going to correct our Luma range, or our dark and light values, and we'll do that in conjunction with reading the Luma Waveform so we can accurately map the dark and light values accordingly. It's at this point that we also make sure that our flesh tones are registering around 65 to 75%. Then we balance our color channels, and we use the RGB Parade to do that. So that's where we make sure that the neutral parts of our image, the shadows and the highlights, are in fact color neutral. So in an example like this, we'll need to lower the blues in order to remove our cool color cast. Then we make further hue and saturation adjustments, and we use the Vectorscope to help us out there. This is where we do things like make sure our flesh tones are residing along the flesh tone line and adjusting our saturation levels for the image. All right, so we've gone through the scopes on this first image here, but feel free to study the video signal reading of the following two images based on what we just learned so that you can get a sense of the image's contrast, color balance, and hue and saturation.